Hi everyone! Do you like flowers? Are you curious about why and how developers use flowers in their daily work? If so, welcome to my presentation. My name is Nan Yam. I am currently doing my PhD in Eindhoven University of Technology. Today, we are going to talk about reasons for using flowers in model-driven engineering practice. So the flowers that we are going to talk about today is not a nice painting over here, but flower models here, which is a type of state machine model. So state machine models are often used by developer to develop the software of the behavior of the software system, modeling how software change from one state to another given a certain trigger. Apart from using state machine to sketch the ideas and to communicate with other engineers, in model-driven engineering, developer also use state machine models to verify the correctness of the software behavior and to generate code automatically. Many modeling guidelines suggest that it is only meaningful to use state machine if you want to model the change of software state. The flower models, which has only one state with a lot of self-transitions, violate these modeling guidelines as the state of the software stay the same no matter what inputs you give, and there's no restriction on the order of your input. So in this small example, you can actually stop the system before starting the system, although you wouldn't consider it as a logical software design. However, we have seen few modeling cases in the literature where developers use flower models. It remains unclear why developers violate the guidelines, why developers use flower models in their practice. So we would like to study this phenomenon. We would like to understand why a certain modeling guidelines are violated by developers in order to propose some actionable suggestion to the researchers and to their tool builders. So we have mainly four questions about this little flower. We would like to understand how commonly developers use flower models in their practice and the role those flower models play in the system design, as well as why developers use these flowers in their practice. Last but most importantly, we want to know the advantage and the disadvantage perceived by developers. We apply a mixed method called sequential explanatory strategy. It consists of two phases. In the quantitative phase, we mine the software repositories to identify flower models and to understand the role flower models play in the system design. Our findings are then explained in the qualitative phase by interviewing developers. We conduct our study at ASML, which is a leading company manufacturing a lithography machine. This company adopted model-driven engineering to design the software that controls machine actions. One of the modeling tools that they use is called AST, which is a commercial modeling tool widely used within the company to design their software and to automatically generate part of their production code. Let me now introduce some basic concept of AST modeling. Let's look at this small system. So we see three software modules here: alarm, sensor, and siren. In AST, there are two types of state machine, namely interface model and design model. interface models serve as the communication protocol specified how software module communicates with each other. And the design model specify the implementation logic of a software module. Developer can also reuse some handwritten code to implement the logic of the software module. So in this small example, the interface model iAlarm is implemented by design model alarm, which use the service provided by a module sensor and the siren according to the interface model specified here. After specifying these two types of models in the system, developer can enable the verification tool to check the correctness of the software. For example, for this alarm module, the tool checks if design model alarm correctly implements its interface model and use sensor and siren according to what has specified in the interface models here. So after verification, developer can just enable code generations. We obtain all components developed with ASD within this system, except for those that are not accessible due to international legislation. These 26 components contains more than 900 interface models and around 576 design models. So in total, we got 1,500 models. Now let's look at our results. So we found that 25 out of 26 components have flower. More than 350 interface models are flowers, making up more than 38% of interface models. In contrast, only 26 flowers are design models. So we have seen that flower models are widely used in modeling interface model. So we decided to investigate why developers use flower models for interface modeling in particular. However, investigating the reasons for each flower one by one by interviewing developers can take a lot of time from our developers, which is unrealistic. Therefore, we would like to study more. We would like to understand the features of these flower models before heading to our developers. So what we did is that we divided interface models into two groups based on whether a model is sitting at the boundaries of the words of a model. We conduct feature exact tests to identify the relation between sitting at the boundaries and being a flower. And the results suggest that developers often use flowers at the boundaries, especially for large components. We also expect that the name of models can also reflect the role and responsibility of models. Therefore, we tokenize the name of the models. We found that some words are repeatedly and exclusively used for flowers, such as words data and foreign. After identifying the features of flowers, we now can go to our qualitative phase. We conduct a set of semi-structured interviews with the architect and the software developers who design the model. With our quantitative findings, now we can ask more insightful questions. So for example, we ask why developers use flowers on boundaries. And then we made transcription of those interviews and we conduct coding to identify the reasons. In particular, we look for the goal that developer would like to achieve and their corresponding solutions. And after that, we got a set of reasons. Then we try to assign the reason to flowers. So for each flower, we try to assign the reason that we identify in the previous in the interviews. We conduct more interviews if there's a flower that cannot be explained by the identified reason. And we stop the iteration once all the flowers can be explained by the reasons. Eventually, we identify 10 goals that developers are trying to achieve with design patterns using flowers. And these 10 goals are grouped into 4 main reasons. The majority of the flowers are used for dealing with different kinds of tool limitations. Later, I will give some examples. Since the company has a large portion of software developed with a traditional coding practice, so around 20% of flowers are used as a part of design patterns to integrate models with those existing code-based components. We also found a small portion of flowers are there for facilitating developers' long-term maintenance goals, such as low coupling and less code changes. We also found one case where developers simply want to reduce the verification time. So if you are curious about how developers use flowers in their design patterns to achieve their goals, please find more details in our paper. Here, I would like to briefly name few examples where developers use flowers to deal with tool limitations. So in our case study, it happens that developers want to express a certain idea or certain design, but somehow they cannot express that with the tool. So for example, ASD does not support global data variables for multiple models. Due to this limitation, they have to create a piece of handwritten code to store the global data, and other models need to interact with this piece of code to query and update data. Another case is that the tool does not support sufficient libraries. So for example, to create a timestamp in a certain format, developer write code to implement the functions that use C++ time and date libraries. So we observed that developers write a lot of additional code to overcome these tool limitations. And flower models are there used to glue everything together, because flower models are the most permissive models that can smoothly work with its environment without any restriction. So it seems that developers usually have a good reason to use flower models, but is this always perceived as a good practice? To understand this question better, we discussed the advantage and disadvantage of using flowers with our developers. All of them point out that it is very easy to implement such flower models, as it has no restriction on their order of the function calls, so the verification can pass very easily. On the other hand, developers also concerned that the loss of verification power is risky, as it might hide bugs. So it seems that there's a trade-off between modeling effort and the risk of introducing bugs. Our result provides a suggestion to both researchers and tool builders. First of all, we can help developers investigate whether flower models can actually reduce coupling and reduce code changes as they expected. Second, our results suggest that there's a trade-off between modeling effort and the risk of introducing post-release bugs. So we can help developers make a trade-off by studying how flowers actually impact development, maintenance, and verification. Important considerations are modeling time and the number of post-release bugs. We have seen that a significant portion of flowers are used to integrate models with existing code base, which implies that tool builders should consider the automation of integration when designing their modeling tools. In our study, we have also identified some tool limitations. For example, the one we just discussed. Because of this limitation, developer often need to add additional handwritten code to express the idea that cannot be expressed with the tool, which also implies that the tool builders should consider how to minimize the need to write additional code. Now let me summarize what we have learned from this study. So we learned that developers have 4 main reasons to use flowers. Besides that, our study also suggests that there's a trade-off between the effort spent in designing a model and the risk of introducing issues due to the loss of verification power. And the important consideration for resolving this trade-off are the modeling time and the number of post-release bugs. Okay, so thank you for watching my presentation. So if you have any questions or comments, please feel free to drop me an email. Our Q&A session will be on Zoom in 29th of June. Looking forward to meeting you there. Enjoying the conference and stay healthy. Goodbye.